So now we're going to look at the definition of the derivative at a particular point. So if you notice here, there are two different formulas that we could use, and they're very similar. The top one looks very similar to what we talked about previously with the definition of the derivative. So we have, instead of x, we have a in place of x. For the second one, the one on the bottom, that looks similar to what we did in the previous lesson with the rates of change. So sometimes you're going to see one or the other. They are both used, they're pretty much interchangeable. Depending on the function, you might think that one is easier to use than the other, but it's really important that you understand that they both mean the same thing and how to interpret them, which we're going to look at in a little bit. So what we're going to do is we're going to look at how to find the derivative at a point, and I'm going to kind of throw it more into a little bit of context, and we're going to look at each example. So the first example is going to deal with this top function. Okay, so find an equation of the tangent line to the curve y equals the square root of 2x plus 1 at the point 4, 3. So remember that the derivative is the slope of the tangent line, right? So instead of just saying, use the limit definition of the derivative to find the slope at a point or find the derivative at this point, this is more asking us to do some more things, right? It's trying to find the equation of the tangent line. So in order to find the equation of a line, we first have to start with the slope, and then we can actually make the equation of the line. So I'm going to use that top formula for this. So what I'm going to use is the limit as h approaches 0 of f of a plus h minus f of a over h. Now you could use the bottom one if you wanted to. You should get the same exact thing. Like I said, we're going to do this example this way just to see. So a is a point, a is a number. Whenever we're given something like this where they give us a point, instead of just saying like x is equal to whatever, use the x value of the point for a. Okay, so here's the x value. X is going to equal whatever a is supposed to be. So in this case, we'll say a is equal to 4. So instead of a plus h, we're using 4 plus h, and instead of a, we're using 4. So what I'm going to do over here on the side is I'm going to figure out each piece so I can plug them in. So first I'm going to do f of a plus h. So I know that that's the same thing as f of 4 plus h. So what I'm going to do is plug that right into my function. So 2, and then instead of x, I'm going to do 4 plus h plus 1. So if I distribute the 2 and add the 1, I end up getting 2h plus 9. Sorry, square root of 2h plus 9. So that's what f of a plus h is. I'm also going to find out what f of a is. So f of a is really f of 4. So again, I'm just going to plug 4 in. So square root of 2 times 4 plus 1. So this is equal to the square root of 9, which is 3. So now what I'm going to do is I'm going to go back to my limit here, and I'm going to plug in my information. So I'm going to do the limit as h approaches 0. So f of a plus h, well, we said that that was f of 4 plus h, and we figured out that it was that. So square root of 2h plus 9. And then I'm going to subtract f of a, which is f of 4, which is 3, over h. Okay, so normally when we have this, we would plug in our limit first, so plug in the 0 for h, but we get 0 in the bottom. So when you get 0 in the bottom, your next step is to try to use algebra. Since we have a square root on the top, we can use the conjugate to rationalize this. So what we're going to do here is multiply top and bottom by the square root of 2h plus 9 plus 3 over the square root of 2h plus 9 plus 3. So very similar to when we just were doing limits with algebra. All right, so this is going to give me the limit as h approaches 0. If I FOIL out this top, I'm going to get 2h plus 9 and then minus 9. And on the bottom, I'm just going to have h and then the square root of 2h plus 9 plus 3. So all of this should just be a quick review. So if I try to simplify this, the 9s will cancel. So I have 2h over this bottom. And then I can factor out my h from the top and the bottom. So I end up with the limit as h approaches 0 of 2 over the square root of 2h plus 9 plus 3. If I plug in 0 now, I end up with 2 over the square root of 9 plus 3. So this gives me 2/6, which is 1/3. So we found right now the derivative at 4. So when x is equal to 4, we found the derivative of that function because we found the slope. So I'm just going to put in parentheses here that that is the slope. Now, if the question was just find the derivative, we did it. Great. But we want to find the equation of the tangent line. So we know that the derivative is the slope of the tangent line. So 1/3 is our slope. And then we're just going to go back to like algebra 1. And I'm going to use point slope form. So in case you forgot what that is, y minus y1 equals m times x minus x1. And I'm just going to use that 0.43. So I have y minus 3 equals my slope of 1/3 times x minus my x value, which is 4. And the cool thing about like the AP test, we'll go through like what's accepted and things like that, but you don't need to simplify for the AP exam on open-ended questions. So this is perfect. Once you plugged it in, you can leave it like that. You don't have to solve for y. If you wanted to, right, you would get y equals 1/3 x plus 5/3. That's just if you like to solve for y. Sometimes it's useful to solve for y because they're going to ask for a second piece to this where you'll need to kind of plug something in. So being able to solve for y is important, but you should all know how to do that. So there we go. All right, we're going to do one more. And this time we're going to use the other definition of the derivative. So here we have find the slope of the tangent line to the curve, y equals x cubed at the point -1, -1, then find the equation of the tangent line. So it's basically saying find the derivative and then find the equation. So again, we're looking at a point here. So first thing I notice is the x value, right? X, remember we said was a. So here a is equal to -1. So we're going to find the derivative at -1. That will give us the slope. So again, I am going to use the second function that we looked at, the second formula. So x limit as x approaches a of f of x minus f of a over x minus a. Okay, so again, you could use that first formula. It's really up to you, but we're going to do this one this way. So we said that a is equal to -1. So f of x, we're just going to plug in x for the equation, great. And then for a, we're going to plug in -1. So I'm going to go to the side, and I'm just going to plug in f of -1. So that's going to be -1 cubed, which is -1. So I have the limit as x approaches. So a is -1. So we have f of x, which is x cubed, minus f of a, which is -1, over x minus a. So x minus our a of -1. So this is going to give us the limit as x approaches -1 of x cubed plus 1 over x plus 1. Okay, so again, here we have a limit. We can try to plug in -1. Oops, we get a 0 in the bottom. So when that happens, the second thing we need to do is try to use algebra. If you look at the top of this, some of you might remember this. Hopefully you do. If not, look back to Algebra 2 and Pre-Calc. This is the sum of cubes, so I can factor the top. So we'll have the limit as x approaches -1. If I factor that top, it's going to be x plus 1, x squared minus x plus 1 over x plus 1. So now these x plus 1s can cancel out, and we get the limit as x approaches -1 of x squared minus x plus 1. So now I can plug in -1 right into here, and we end up getting 3. So again, that is our slope. That's the derivative at -1. That's the slope of our tangent line. But we want to find the equation. So once again, I'll use point slope form. So I'm going to do y minus the y value. So that's -1 equals the slope, which is 3. And then x minus the x value, which is -1. So just to kind of clean it up, I'll put a little arrow here. We get y plus 1 equals 3 times x plus 1. So again, we don't have to do anything with that. We can leave it. If you wanted to solve it, we would get y equals 3x plus 2. Both are correct, whichever way you would like to write it.